Hello, my name is Panos Ritsos and I'm a lecturer in the School of Computer Science and Electronic Engineering. I will be talking to you about some of our recent world-class research work and explain how these activities inform our teaching and how you as a student at our school can be involved in this work. Our school has a long tradition in research in immersive technologies, whether for medical applications, simulation and training, cultural heritage or entertainment. In this work, we use technologies such as hand-mounted displays, very much like this, position and posture sensing technologies, and advanced computer graphics to immerse users in computer-generated environments. One of the specific research themes we explore here in Bangor is Immersive Analytics, where users are immersed in data. Immersive Analytics make use of different interaction paradigms such as mixed and augmented reality, virtual reality, collectively called XR. Think of XR as a variable for all the different underlying technologies. These interaction paradigms allow us to create either completely computer-generated worlds, as we do in VR, or superimpose computer-generated information upon our physical world, as we do with augmented and mixed realities. Of particular interest to our vision is the notion of augmenting our world through data-driven interactive networked objects, some of which are physical, some of which are computer-generated. Effectively, this is a fusion of display technologies, graphics, data, and ubiquitous computing in a way that provides a real-time, always present informational layer upon our physical world. Our motivation for this vision comes from many different observations. We live at a time where the way we interact with computers is evolving. Technologies like virtual and mixed realities and the Internet of Things change the way we understand our informational space and physical space. At the same time, data pervades all aspects of our lives. And as we see during the current pandemic, determines our response to the big challenges we face. The production and consumption of said data is constantly increasing, and we are looking for new ways to visualize and therefore understand and interpret our data. In this technological evolution, we are aided by disruptive technologies such as our smartphones, faster communication networks which make computing services accessible even on the go. At the same time, advances in interfaces and display technology change the way we interact with our computers and generate new opportunities for research and user experience. We are gradually taking steps away from our desktop environments in a world of ubiquitous data-driven information, in worlds which have been portrayed in science fiction and movies for quite a while. In addition, visualizing data has become one of the most powerful ways to understand it. The web has been the de facto platform for data visualization, especially during the past decade. There are many web-based tools that have been transformative of how visualizations such as interactive dashboards and infographics are being created and disseminated to the public. In Bangor, we have a long history of developing data visualizations on the web, with example applications focusing on water resource management, such as the one shown, cultural heritage, learning analytics, and health and medical sciences. It is therefore natural to explore how we can use the web for the immersive visualizations as well. The web is an ever-present, always-on platform full of information that allows the interactive manipulation and analysis of data. It is easily accessible and has been a significant enabler of collaboration. Therefore, the so-called Immersive Web has the power to bring all these concepts together. However, implementing fast graphics needed for XR-based visualization in a browser is a challenge, and that is why many developers often prefer to rely on the capabilities of game engines and therefore do not use the web. Game engines being the software that people use to create modern computer games. In Bangor, we have taken up on this challenge, and we have focused entirely on the web, and we have pioneered work which combines XR technologies and web technologies based on cutting-edge emerging standards such as WebXR. We have created tools that allow building immersive analytics accessible via the web on smartphones, tablets, head-mounted displays, and standard desktop computers with a single code base. That is, the same code works with many standard compliant devices. Here you see some examples of our early work. On the far left, a 3D bar chart seeing in VR mode on a smartphone. The rest of the pictures depict the 3D bar chart superimposed on a pair of printed markers, one of which controls the data and the other one controls the depiction type. By mixing and matching printed markers in the physical world, we change the computer-generated visualization. Our recent flagship project called Vria is a framework for building immersive analytic experiences with the intention to be used in research of use cases and application scenarios. It has been recently presented in a leading conference and is available as a Node.js module, which has been downloaded over 3,000 times since October 2020. Veria uses popular web frameworks such as React and A-Frame and allows the creation of 3D visualizations with simple declarative format such as the one shown in the examples in the slide. The declarative format will specify what the visualization is going to look like, but it won't specify how you're going to create that visualization. That is taken care of from our framework. The framework can also be extended with established web libraries such as 3JS, as well as its own API. The outputs can be easily integrated in another web interface and can be accessed using contemporary head-mounted displays like the Oculus Go, Microsoft HoloLens, and so forth. We have also built in support for libraries that allow online collaborative data manipulation as well as support for augmented and mixed reality. At the top, you see the avatars, two simple avatars of two users who are in different locations interacting with our 3D visualizations, all this done via their browser. At the bottom, you see a simple demonstration of how a simple AR marker can be used to place a computer-generated object upon our physical world, in this case, an office desk. Moreover, Veria can be accessed by users of different expertise. Novice and intermediate users can use the online builder, which I will be soon demonstrating, whereas seasoned developers can use Veria's API. The software is available on GitHub in the link displayed on the slide, so feel free to use it, test it. That's where you're going to find the builder as well, which I'm going to be demonstrating now. This is the main view of the builder, which is accessible in the URL that you see at the top in the address bar. And probably the easiest way to explain things is to use one of the examples which are already into the system. So if you choose the examples, you can find various different depictions. Probably the most interesting, or the ones that look cooler, I suppose, are the 3D bar charts, which use a very various unique color schemes as well. So you have X, Y axis and Z axis depictions, and you also have various other additional information, the labels and the legends of your visualization. What's quite interesting is also you can interact with the mouse cursor with these. The cursor, depending on what kind of device you have in head-mounted displays, for example, or mobile phones, you have either a cursor at the center of the screen, or with head-mounted displays, you can interact with the pointers, the controllers, the hand controllers that usually come with this, with the head-mounted displays. You can change the marker, so you can have filters as well, which control the how many of the values do you present in each case. And this one also has tooltips. Probably the most interesting examples, I suppose, are the linked views, where you can have a data set with various different, various different aspects of the data sets in different graphs, in different coordinated visualizations, which you can make selections again with the menu, or you can apply one of the filters. In this case, for example, in this part of the visualization, and you'll see the corresponding changes in the other visualizations. So what is quite interesting with this is that the way that it's configured. So instead of actually worrying with how you're going to build this to begin with, that's been handled by the toolkit. But what you do is basically using the declarative format that I mentioned, you configure how the visualizations, what the visualizations are going to depict and how they're going to look. So in this case, this is the dataset. So the larger part of this configuration file is the dataset. And towards the end, we have various configuration variables. So for example, how many views we're going to have, what kind of marks we're going to use. In this case, we're using spheres. The configuration of the tooltips as we have here, and where exactly they're going to be placed, and so forth. So this is a simple demonstration of how the builder works. Feel free to play around with it, access it. It's available for everyone. What you can also do is download the code. I mean, if you are brave enough and you want to explore the documentation, feel free to play around with it. It's available for everyone to use. So how does this research inform teaching, and how can you be involved? The technologies used in this research are being taught from year one, and modules such as web technologies which form the basis of this work. Aspects of user experience evaluation and interaction design are being taught during the second year in modules such as user experience and human-computer interaction. We also have modules that teach aspects of artificial intelligence, game design, computer graphics, and the usage of these technologies in broader application scenarios. A more detailed investigation of matters relating to XR and X realities can be found in master's programs. The best opportunity, though, to create similar applications and systems is during the third year and your final year project, when you will work under the supervision of the school's academics on a research-led project closely related to our research activities, combining knowledge from different modules. We also have undergraduate internships opportunities throughout the year, many of which are also informed by our research. Thank you very much for your attention. I hope you found this very exciting, and we're looking forward to welcome you at the School of Computer Science and Electronic Engineering.